Alright, so for today's lesson, what we're going to do is we're going to be continuing on with double angles. This is going to be our specialty for the week. So, let's take a look and see what I have in store for you. Today is the 31st. It's actually my brother's birthday today. His name is Justin. So anyway, we have section 5.5, and it's called double angle identities. So we're going to be solving the following equations. And the equations look like this. 2 times the cosine of x plus the sine of 2x is equal to 0. So taking a look at this, we do have a double angle identity. So I'm going to replace this with the formula. And then the way that we solve equations, first step is we look to see if they're basic, then we try to factor. We could use completing the square, quadratic formula. We have that whole list. But clearly we could take a 2 cosine out of this whole thing. And we're left with 1 plus the sine of x equals 0. At this point we set the factors equal to 0. So cosine of x would be 0, and that happens right here and right here. So x would be 0 radians, and x would be pi radians. And if there's no restriction, we always add the period. Let's do the other half. Bring the 1 over. Sine of x is negative 1. Well, sine of x would be negative 1. The y value right here at 3 pi over 2. And because there's no restriction, we're going to add the period times k. Okay, let's try something else. What about the tan? And if you have any questions, just yell out and I'll stop, okay? Tangent of 2x minus cotangent of x equals 0. So I'm going to use the formula. Tangent of 2x is going to be 2 times the tan of x, ax. Divided, I'm laughing at myself, guys, sorry. 1 minus tangent squared of x. And cotangent, let's just write everything in terms of the same trig function, minus 1 over the tangent of x. So at this point, what I'm going to try to do is get common denominator. So common denominator, this one's a little bit tricky. But usually if you don't know what a common denominator is, we just use both denominators and multiply them together. So that's what I'm going to do here. I'm going to multiply this one by tangent of x over tangent of x. And this one by 1 minus tan squared of x divided by 1 minus tan squared of x. So we would have 2 times the tangent of x times the tangent of x minus 1 times 1 minus the tangent squared of x, all divided by the same denominator. Equals 0. So now the way that we solve a problem like this, we'll simplify the left, and then we'll set the denominator equal to 0, and we'll set the top equal to 0. So let's see what we get. On top, we get 2 times the tangent squared of x minus 1 plus the tangent squared of x, all divided by tangent of x times 1 minus tangent squared of x. Just turns into 3 times the tangent squared of x minus 1 divided by tangent of x times 1 minus tangent squared of x equals 0. Okay, So, in order to do this, we have a rational equation. What we're going to do is we're going to set the top equal to 0, and then we're going to make sure that none of those answers make the bottom equal to 0 either. So let's do the top first. 3 times the tangent squared of x minus 1 equals 0. Bring the 1 over and divide by 3. And we're going to take the square root. This is absolute value. And we get that the tangent of x is going to equal plus or minus 1 over the square root of 3, which is actually two different answers. When is tangent of x equal to 1 over root 3? And when is tangent of x equal to negative 1 over root 3? Well, in order to get 1 over root 3, that's a 30-degree triangle. So tangent would be positive here, and tangent would be positive here. So we get the answers. 30 degrees is just pi over 6, and 210 would be 7 pi over 6, plus the period. Okay, so again, this was 30 degrees and this was 210. I just did the conversion in my head. To get negative 1 over root 3, we're going to draw a tangent where it's positive. One of the angles would be 150, and the other angle would be 330 degrees. So this would be 150. If you convert that, that's 5 pi over 6, plus the period. And then 330 would be 11 pi over 6, plus the period. All right, and we just want to make sure that none of those angles intersect with this denominator. You can't have 0 in the denominator of a fraction. So just on the side, when is tangent of x 0? And when is 1 minus the tan squared of x equal to 0? I just want to make sure there's no overlap. Tangent would be 0 when the y value is 0. The y value would be 0 at these 2 points. When x is 0 plus the period, and when x is pi plus the period. So that would never intersect with any of these angles. So we don't have to worry about that. And 1 minus tangent squared this would happen at 45 degrees. I'm drawing it where 1 would be positive and also where 1 would be negative. And there would be no overlap here. All right. Most of the time we're just okay cross multiplying to solve. But remember what we said, every once in a while you might wind up canceling out possible answers. So that's why I did that over here. A couple more examples for us today. What we're going to be doing is we're going to be rewriting using a double angle identity. And the first problem looks like this. 6 sine of x cosine of x plus 4. And I want to write that using a double angle identity. Well, I know that 6 times that is really 3 times 2 sine of x cosine of x. And this is a double angle identity. So we could say this is the same thing as 3 times the sine of 2a plus 4. That would be what I expect you to do for a problem like this. And then the second example and our last example today says we're going to write cosine of x plus the sine of x times cosine of x minus sine of x as a double angle. So the way we could do this is just FOIL it out. Cosine squared of x minus sine x cosine of x plus sine x cosine of x minus sine squared of x. And this one's pretty easy. These cancel. And we get cosine squared of x minus the sine squared of x, which is just the formula for the cosine of 2x. All right, so for homework tonight, it's gonna be attached to this lesson, but I'm gonna call it the Cilio Day 2 worksheet. All right, please try that. And have a nice day. Thank you.